Have you ever wondered what secrets the Sun, our very own star, holds within its fiery depths? This radiant celestial body, a mere 93 million miles away, is more than just a glowing orb that gives us daylight. It's a life-giving powerhouse, without which our existence would be impossible. It fuels our planet, driving the photosynthesis that breathes life into our forests and crops. Yet the Sun is also an enigma, a cosmic mystery that continues to baffle us. Solar phenomena like solar flares and coronal mass ejections, which have the power to disrupt our technology and communications, remain largely unexplained. And let's not forget the Sun's corona, hotter than the Sun's surface, a paradox that leaves scientists scratching their heads. To understand these mysteries, we must journey into space, get closer to our star, and study it like never before. But how can we uncover these secrets? One word: exploration. Space exploration has taken us to the Moon, the Mars, and even beyond our solar system. But the Sun, our closest star, remained a challenge. Our journey to the Sun began in earnest in the mid-20th century. The Pioneer 6, a NASA satellite launched in 1965, was the first to venture close to the Sun. Its mission was to study the solar wind and cosmic rays. Although it provided valuable data, the extreme heat and intense radiation from the Sun posed significant challenges. Next came the Helios spacecraft, a joint venture between NASA and Germany's space agency. Launched in the mid-70s, the twin Helios probes set a record for the closest approach to the Sun. But again, the Sun's unforgiving heat and radiation proved to be a formidable adversary, limiting the duration of the mission. Then, in the late 80s, we saw the launch of the Ulysses spacecraft. This was a joint mission by NASA and the European Space Agency. Ulysses was the first spacecraft to observe the Sun's poles, providing a unique perspective on solar activity. However, it too faced the wrath of the Sun's intense energy, which ultimately ended its mission. In the 21st century, NASA's Solar Dynamics Observatory and the Solar and Heliospheric Observatory, a collaboration with the European Space Agency, have been observing the Sun from the safe distance of Earth's orbit. They've been instrumental in providing real-time data on solar activity, yet the Sun's mysteries remain largely untapped. The Parker Solar Probe, launched in 2018, is the latest attempt to approach the Sun. It aims to get closer to the Sun than any previous mission. While it continues to brave the Sun's heat and radiation, the data it collects will be crucial in understanding our star better. Despite the challenges, our thirst for knowledge kept us pushing, leading to the conception of an ambitious mission, the Aditya L1. Enter Aditya L1, India's first solar mission, a giant leap in our quest to decode the Sun. This ambitious project, spearheaded by the Indian Space Research Organization, or ISRO, is no ordinary mission. Aditya L1 is set to journey nearly 1.5 million kilometers from the Earth to a point known as Lagrange Point 1, or simply L1. So, what's special about this mission? Aditya L1 is designed to observe the Sun's corona, the outermost part of the solar atmosphere which is visible during a total solar eclipse. This is no easy task. The corona, with temperatures soaring over 1 million degrees, is much hotter than the Sun's surface, a phenomenon that has long puzzled scientists. Aditya L1 aims to unlock the mysteries of this high temperature. The mission's main instrument, the visible emission line coronagraph, will study the corona's dynamics and its connection with other layers of the Sun. This will provide vital insights into the various processes of the Sun and how they affect space weather. Understanding space weather is crucial. It influences the performance of our satellite technologies and can even impact power grids on Earth. So, by studying the Sun, Aditya L1 will also help us better prepare for and mitigate these effects. With Aditya L1, we are not just exploring the Sun, but also paving the way for future space explorations. So, why does the Aditya L1 mission matter? Well, it's the key to unlocking a wealth of knowledge about our Sun and its activities. By studying solar storms, we can predict their occurrence and protect our satellites and power grids from potential damage. This mission is not just about exploration, it's about preservation. Aditya L1 is advancing our understanding of the Sun and space weather, providing insights that could shape our future. Aditya L1 indeed is more than a mission, it's a beacon of hope for a future where we coexist with the Sun, understanding and embracing its many